Hey class, and welcome back. I wanted to give you all a help video on this homework problem here. I know it's a pretty tricky one for some of you, and for really anybody pretty much, and so I wanted to talk about it a little bit. So what you see here is we're told a little bit about kind of this lob shot where you sort of gently loft it over the head of someone, hoping that they can't get back in time to return it very accurately. So one player is up at the net, shown here, and the other player is hitting the ball at 15 meters per second at a 50-degree angle, and the distance between the two players starts at 10 meters, and you're asked to figure out, for this person here, in order to get back in time to return the hit, what must their average speed be, or what's the minimum average speed to just barely make it? Now, because people won't react instantly, like the moment it comes off the racket, they already know where it's going and start running back, there's some sort of time delay in their reaction time that I'm going to just call that, maybe T with a subscript D for delay, but there's some time delay before they start running. So the reaction time, the amount of time they have to get back, which I'll call TR, is going to be whatever the total time that the ball's in the air minus that delay in their time, okay? So why do I care about the time? Well, we're asked to find, again, their minimum average speed, all right? So average speed, velocity average, right, is distance over time. And so what that means is their average speed must be such that they cover the distance they need to, I'm going to label D, from where they're at to where they need to get to hit it in the amount of time that's left after the delay from their reaction time. Okay, so sounds good. The only problem is what's D and what is this reaction time, right? So in order to find the reaction time, we must find the total time that the ball's in the air, and then to find D, let's look here. So if this is our overall final X position, right, then D is going to be that overall X position minus the 10 meters that the person is already away from where the ball is hit. All right, so to find our average velocity, we can take D and the reaction time and solve. But the question then is, what is the total hang time of the ball, T, and what is X, the range or the distance that the ball goes horizontally? So some of you might, to find X, you're like, oh, I'll just use the range equation, piece of cake, and then I can go from there. But it's not that easy. Since it's landing 2.1 meters above where it starts, you cannot use the range equation. So we want to find T and we want to find X. So to do that, well, we have a standard, projectile motion type problem. So to follow the process that we need to do, we need to take everything, break it into X components and Y components, and go from there. So to help you get organized here, I'm going to break things down into X and Y components using actually two different colors. So I'm going to start just with my X direction and X variables. So I know that X final, we don't know, we're trying to find. X initial, I'm going to go ahead and call 0. So I'm defining this as the starting point and the 0, 0 point on my axes. All right. Acceleration in the X for projectile motion is always 0 meters per second squared, right? Initial velocity in the X is going to be our initial velocity of 15, which we know, multiplied by the cosine of 50 degrees. Again, if we go ahead and put our axes in here, I'll do them in yellow so they're just kind of light. So if that's my Y and here's my X, we can see that we can make a little triangle with our initial velocity here. Here's our initial velocity. And so it's going to have a Y component, a vertical component, and a horizontal component. So the X component is the adjacent side. That's where that 50 degrees comes from. My final velocity in the X is just equal to my initial velocity in the X, since there's no acceleration. And then the time we already established, we don't know. Okay, So if we were to start in the x direction, since it's the x variable that we care about, we look at our equations of motion, and as we go down, we see that many of them have acceleration, which will be equal to 0. So two of the equations of motion just tell you this truth. And so the only one that's really helpful in the x direction is x final equals x initial plus v initial x times time plus 1/2 the acceleration in the x direction times time squared. And so you can see we know that this is 0, and we know that this term is 0, and so we are just left with, I'm going to scroll up just a little bit here for us. So we're just left with x equals v initial cosine of the angle 50 multiplied by time. Cool. Well, not that cool, actually. Since we don't know x and t, those are the two things we want to find. One equation with those two unknowns, not that helpful. So then we have to consider our y direction. So I'm going to now return to the y direction and do that in blue, and again start with my variables. So now we're looking at the y direction. Y initial we're going to call 0. Y final we know to be equal to 2.1 meters. V initial in the y is v initial times the sine of 50, as we saw earlier. V final we don't know, and acceleration in the y is just negative g, or negative 9.8 meters per second squared. So the question is, since we want to find x and time, can we use the y information to find time and then plug it in over with the x? Okay, so this is one thing I've noticed that some of us have been having a hard time with, okay? You need to keep your x and y variables separate. I never want to see a mixed equation where you have like an x distance with acceleration due to gravity. That doesn't work. Your equations are for either x or y. The one thing that links the two is time and time alone. All right, so make sure you stay really organized with how you're doing this. You can do all the equations of motion with the x and all of them with the y, but it has to be done separately and only combining via time or the initial velocity when you're breaking it down into its components. Okay, since that's the hypotenuse, you see that in both cases, but one case the x is v cosine and the other is v sine for the y. All right, so if we want to figure out the time and we know positions and initial velocity, you should be drawn to the same equation we used in the x that says y final equals y initial plus v initial y times time plus 1/2 acceleration in the y times time squared. So if we substitute in the things that we know, y final we know 2.1 meters equals 0 plus v initial sine theta times time plus 1/2 negative g times time squared. So v initial sine of the angle, sine of 50, I guess we already established that as 50, so I can plug that in. And v initial we know is 15 meters per second, so I guess I could have plugged that in. And we know g, so everything is known here except for time. So I'm going to rewrite this equation, moving everything over to the left side of the equation. So the negative 1/2 gt squared becomes a positive 1/2 gt squared. Then the v initial becomes negative, so v initial sine of 50 times time, and then plus the 2.1 meters, and that's all equal to 0. And if you notice, now we have a quadratic equation where you have a t squared plus b, which b is a negative v initial sine 50 times t, plus c. You can solve this quadratic equation. So I'm not going to do it for you, but you solve this quadratic, and since it's a quadratic, you're going to get two different times. All right, so I'm going to scroll just a little bit here again. So you're going to get some t1 equals a number that's going to be quite small, and then some t2 that equals a number that's larger. Why are there two solutions to this quadratic? How do you know which one to use? Well, let's go and look. What you're solving is for the point in time at which your tennis ball is a distance of 2.1 meters above where it started. So if you look here, it's going to reach it at one point here, but it's also going to be 2.1 meters above right here. So the shorter time, which I called T1, will be here when it's on its way up, and then T2 is going to be over here when it's on its way back down. So when you solve this, even though there's two solutions and you might feel a little bit confused, you do not want T1. That's when it's on its way up, the shorter time. You don't want to use that. The T that you're trying to find is T2. So once you get T2, you can plug it in. You would then be able to solve for x equals some value. And once you have x and T2, this here up here, we might as well add the subscript now. This is the T2 that we just found. You can use that to find the total reaction time, and then you can use your x to find d and find the average velocity. So that's a bit of a boy howdy kind of crazy problem, right? But it's a good one to really show you the full process and all that these simple equations are capable of, especially if you want to get better at tennis or better at physics. Anyway, so yeah, try that out, solve it. Let me know if you have any questions or run into any problems, but I hope that helps. Have a good day.